Irrational and real numbers. Introduction of numbers, rational numbers, decimal form of rational number, terminating and non-terminating, irrational number, square roots of numbers that are not perfect squares, and real number. In your earlier classes, you have learned about the number line and how to represent various types of number on it. In this lesson, let us learn some more methods. Just imagine, you start from 0 and go on walking along this number line in positive direction. As far as your eyes can see, there are numbers, numbers and numbers. Now suppose you start walking along the number line and pick up 1, 2, 3, 4 and put it to your bag. Now your bag contains infinitely many natural numbers and we denote this collection as n. Now turn back, walk and pick up 0 and put it into the bag. Now this collection is collection of whole numbers and denoted by W. Now start collecting all negative numbers and put it in the bag. This collection becomes integers and it is denoted by Z. Are there some numbers still left on this line? Yes, there are -1/3, 1/2, 1/4. If you put all such numbers into bag, it will be the collection of rational numbers and denoted by Q. Rational numbers. A number R is called a rational number if it can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. For example, -12 can be written as -12/1. Here P is equal to -12 and Q is equal to 1. Therefore, -12 is rational number. The rational numbers also include the natural numbers, whole numbers and integers. The decimal form of rational number. Let us take 3 examples. 10/3, 7/8, 1/7. Pay special attention to the remainder and see if you can find any pattern. If you observed carefully, you should have noticed 3 things. 1. The reminders either become 0 after a certain stage or start repeating themselves. 2. The number of entries in the repeating string of reminders is less than the divisor. For example, in 1/3, 9 repeating itself and reminder 1 is less than divisor 3. 3. If remainder repeat, then we get a repeating block of digits in quotient. For example, for 1/3, 3 repeats in the quotient and for 1/7, we get the repeating block 142857 in the quotient. From above examples, we have seen that when remainder becomes 0 after some steps, the decimal expansion of number terminates or ends. We call such decimal expansion terminating. When decimal expansion of number goes on and repeats block of the digit in the quotient, we call such expansion is non-terminating recurring. Convert a terminating decimal in the form of a non-terminating recurring decimals. No matter how many zeros we write after the last digit in the terminating decimal fraction, the number obtained has the same value as the original number. Using this property, a number in the form of a terminating decimal can be written in the form of a non-terminating recurring decimal. Thus, the decimal form of every rational number can be written in the non-terminating recurring form. Non-terminating recurring decimal forms and rational number. Every rational number can be written in the non-terminating recurring decimal forms. Conversely, is every number in the non-terminating recurring decimal form a rational number? The answer is this question is yes. Thus, every number in the non-terminating recurring decimal form is a rational number. Irrational numbers. A number S is called an irrational number if it cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Root 2, root 3, root 5 are irrational numbers. In another word, number whose decimal form is non-terminating but is not recurring are called irrational numbers. Square roots of numbers like 2, 3, 5, 6, 7, 8, 10 and so on, which are not perfect squares, can be found by division method. In these values, no digits are found by recurring. In other words, the decimal form of these numbers is non-terminating and non-recurring. Such numbers are called irrational numbers. The square root of numbers that are not perfect square are called irrational number. Now, if you put all the irrational number into the bag, what will there on the number line? Nothing. Therefore, all rational and irrational numbers together form the collection of real number, and they are denoted by R. So we can say that every real number is represented by the unique point on the number line or vice versa. That is why we call the number line as real number line. Note that every rational number is a real number, and 2. that every irrational number is also a real number. Summary. Dear students, in this topic we have learnt numbers, natural numbers, whole numbers, rational numbers, irrational numbers and real numbers. That is all in this topic. Till then, keep learning.